All right, we're back. We're on page 4 of notes 19 of Calc AB. We were talking about, I don't know what we're talking about. What are we talking about? We're talking about motion and antiderivatives and derivatives because it's all mixed up and we kind of know everything that we need to know at this point. So like this page is just going to cover everything. So let's see what we got. So for 0 to 6, a particle is moving along the y-axis. So it's just like moving up and down, whatever. Y of t is not explicitly given. This is a pretty common thing, actually. The velocity of the particle is given by v of t equals this. The acceleration is given by this. This is kind of weird because, like, you could just take the derivative of v of t and it would give you a of t. The reason that they do this sometimes, not everyone uses a CAS, and if you have a CAS, you would have an advantage on this problem in the event that you needed to exactly know this. So they just give you both pieces of information. So, like, yeah, it seemed strange at the time, but like, not everyone, you got to level the playing field, right? So that's what this question is trying to do. Then we know that y of 0 is equal to 3. All right. I think the first thing I'm going to do is I'm going to define those functions on the calculator. And then I'm going to try to answer all these, obviously. So is the speed increasing or decreasing at 4? Give a reason. Average velocity, which is the average value of the velocity function. So that's how I choose to read this. This, I would say, let's say, here is really the average value of velocity function. If you replace average velocity with average value of velocity function, it's so much easier to conceptually like figure out what's happening. Total distance traveled. All right, so I'm going to deal with those 3 questions after I shift over to the calculator. So let's do that. So calculator, and I'm in radian mode. If you're not in radian mode, oh my God, you're going to get all the answers wrong. It's going to hurt. So v of t colon equals -3 cosine of e. So use this key. For me, it's easier to type exp. So I'm going to do that on the next thing. And then a of t is, I'm going to type in what was given. So exp of t over 3, sine of exp of t over 3. That's that. And you can see like derivative v of t with respect to t is, does this equal a of t? It does. They just give it to you because it's not really fair if somebody doesn't have a calculator that can't find a derivative and you explicitly need that derivative in symbolic form. So it's just given. All right, is the speed of the particle increasing or decreasing at t equals 4? So we know that we need to find v of 4, get a decimal because you need to know if it's positive or negative. So like it's not really helpful if you don't have a decimal. And we need to know a of 4. All right, so I'm going to write down v of 4 is approximately 1.384, 3 decimals always. A of 4 is approximately -2.302. I'm going to say since v of 4 and a of 4, I will switch back to the notes so that you can like see what I've written, but like you know what to write at this point, right? So just try to write it on your own. I'm writing since v of 4 and a of 4 have opposite signs. Speed is decreasing. And when you see how I just wrote speed, you'll be like, what is wrong with this guy? There appear to be 3 E's in what I wrote. I don't know. All right, the next question. Find the average velocity of the particle on the time from 0 to 6. But I read that as the average value of the velocity function because it's easier to conceptualize that. So average value is integral over interval. So I'm going to do the integral of the velocity function from 0 to 6 t over the interval, which is from 0 to 6, so 6 minus 0, and get a value. So, and we're going to write that down. So write down the integral from 0 to 6 of v of t dt divided by 6 minus 0, and then approximately -0.658. Are there units on this? I don't think so. Usually when it's on like an axis, they don't give units. Nope, no units. Find the total distance traveled. So total distance is going to be the integral of the speed. Speed is absolute value of velocity, so we are going to do the integral of, so integral from 0 to 6 of the absolute value of v of t. So I'm doing this very, like, these are the buttons you should be pressing. So if you're not sure, rewind and watch that again. Integral of the absolute value of velocity, so 10.247. So I'm gonna write that down, and then I'm gonna go back. So 0 to 6, absolute value v of t dt, it's approximately 10.247. 247. Okay. Going back to the notes, let's see if what you wrote is the same as what I wrote. I mean, I talked my way through it, but I didn't show you what I was writing. And you want to be getting to the point where you can write these kind of justifications on your own. So let's see. Here we go. And it's blurry. There we go. All right, so is the speed increasing? So I found v of 4, I found a of 4. I wrote them down to 3 decimal places. And I just say, since v of 4 and a of 4 have opposite signs, speed is decreasing. Good answer. Average velocity, I'm thinking is average value of velocity. Integral over interval. Oh, here's where I wrote speed kind of questionably. I don't know what's going on there. There's definitely something extra, but whatever. Integral over interval, and then the approximate sign is useful. Is actually mandatory. And I get this, and then total distance traveled, integral of the absolute value of v of t dt, and that's only an approximation also. All right, what do we got going on? Phew, a lot of questions. Does the particle ever reach the origin on the time interval? I'm thinking that that's kind of like an absolute max question. Oh, absolute minimum, because we start above. So what I'm thinking, so here's my logic. So we start at y equals 3. And then we're going to move, right? So I don't know. I just found that v of 4 was positive. So like, you know, maybe we do this and this and this and this. The question I want to answer is the absolute minimum on the interval from 0 to 6 less than 0? Because if the absolute minimum is less than 0, then I definitely, because the particle's motion is continuous, because the position is differentiable, right? Because the velocity exists at all points. So differentiability implies continuity. So position is continuous. If position goes from positive to negative, position must have been 0. We definitely would have hit the origin. So that's the question I'm going to try to answer. So I'm going to say that y of t is equal to, so y of 0 is 3. So I'm going to say it's 3 plus the integral from 0 to t. I'm writing an accumulation function. 0 to t of v of dummy variable du. Okay, so y prime by second fundamental theorem is going to be v prime of t. No, it isn't. Jeez Louise. It's just v of t, right? It's this thing with the upper bound plugged in times the derivative of the upper down. So it's just v of t. Y prime is v of t. All right, we're doing the candidates test. So y of t is continuous. Therefore, absolute minimum is at an endpoint or a critical point. I'm going to say a critical point where y prime of t equals v of t changes negative to positive, right? Because that would be a relative minimum. Okay, so I'm going to find the critical points. So it's either happening at 0, at 6, or at a critical point where v of t goes from negative to positive. I need the calculator for this, so let's do that. I think I'm gonna do it graphically, because like the graph will help me to determine where v of t is going negative to positive. So I'm gonna graph v of, graphing a function, you have to use x, so v of x. I only care about 0 to 6, and like actually a really good idea is to change the window before you graph, because you can see it starts getting crazy out to the right. Okay, so the absolute minimum is either at an endpoint, so at 0 or 6, or one of these points where we go negative to positive. So really only here's the option. I'm going to add the graph of 0, do menu 8, 1. I'm going to do menu 8, 1, 4 because I have a CX2. If you have a CX1, the original, you do menu 8, 1, 3. And I think they like stopped updating that operating system, so like you will always be doing that. All right, so either therefore at t equals 0, t equals 1.942, or t equals 6. Now what I'm going to do is, while I'm here, I'm going to store this value. So I arrow over it until it says like text and has that hit. Now I'm going to press Control Menu. I can't show that on the like thing on the left. I'm just going to press Control and then Menu, and this should pop up. I'm going to choose Store, and I will store that as C, I guess. I'm going to go back to the calculator page. I'm going to do 3 plus the integral from 0 to, so it's, well, all right, so 0 to 0 is just going to give me 3, or it better give me 3. Then I'm going to plug in the value of C that I found, and then I'm going to plug in 6, because 6 is the other endpoint. So, ooh, look at that. So 6 did it. All right, let's go back to the notes. I'm going to make a table, and then I'm going to like state my answer. So let's see. This is like this classic candidates test question. Well, it's classic application of the candidates test, but it's like a little hidden, right? Because like the question is, do you get to the origin? Different context, same idea. So we got t0. I'm looking at my cap. Oh wait, I wrote it. 1.942 and 6, and then y of t. This was 3. This was 0.133, and then negative 0.951. Okay, but we're not really done, right? So therefore the absolute minimum of y of t is negative 0. What did we write? 951. Oh boy. At t equals 6. Okay, so we didn't answer the question yet. We just found the absolute minimum. So now what I want to do, that 9 is like, you don't want to leave it up to somebody to decide if that's a 9. So fix it. Okay. We have to answer this, right? So I'm going to say, since y of t is differentiable, well, actually, I've already said that it's continuous, whatever. Don't use it. I'm yelling at myself right now, but like I'm also yelling at you. Y of t is continuous since y of 6 is less than 0 is less than y of, you can say 0, or you could say 1.942, like whatever. I'm gonna say 0. Y of t equals 0 for some t element of 0, 6. Therefore, particle or object or whatever reaches the origin. I might move this. I don't know how much space. Oh, I don't have any space. I'm gonna, auto shape. What are you doing? The origin. There we go. Nice. All right. I don't know how long it's going to take me to answer the next couple of questions, but I'm going to stop this video here, and I will come back in the next one, and I will finish this page, because I am pretty confident that that was a very long explanation. So let's cut it here, and I will be back, and we will finish up these notes, and that's pretty exciting. So I will see you there.